show that the following limit does not exist. We have the limit as the point xy heads towards the origin, 0, 0, of the fraction y divided by x squared plus y squared. So we have a point xy. It could be anywhere in the xy plane except for 0, 0. And the point xy is going to move along any path, getting closer and closer to the origin. And as it does so, we would like to know what happens to the fraction y over x squared plus y squared. So to show that the limit does not exist, we simply need to find two different paths approaching 0, 0, which yield different limits. If there's two paths that yield different limits, then the limit doesn't exist. It's similar to in the one variable case, if x is approaching x0 and we're taking the limit of f of x, then that limit would not exist if the one-sided limit and if the left-sided limit and the right-sided limit offered different values of the limit. If one direction gave us L1 and another direction gave us L2 and those were different, then this limit would not exist. So it's kind of similar to that, except for in the one variable case, there's only two directions. Your variable can either be less or greater than the number. But in two variable situation, you have a lot more freedom. The point xy can approach 0, 0 along infinitely many different possible paths. So again, we just want to find two paths where the value of the limit is different. And for those two paths, we will consider moving to 0, 0 along the y-axis and moving to 0, 0 along the x-axis. So let's consider the limit as xy goes to 0, 0 along the y-axis. And that means that x is equal to 0. If we're on the y-axis, the x-coordinate is 0. And so then the fraction is equal to just y over y squared. So xy is going to 0, 0. X is equal to 0. And so we get y over y squared, which is, of course, 1 over y. And as xy goes to 0, 0, 1 over y will go to plus or minus infinity. So already we have a problem because depending on whether y is positive or negative, we have two different answers. So it already doesn't exist just from this one case. But let's look at what happens when xy goes to 0, 0 and y is equal to 0. Then the whole fraction is 0 over x squared plus 0, which is just the fraction 0. So whenever you put any point into this function where the point itself is on the x-axis, then the function is equal to 0. So this function here, f of xy, is equal to 0 if y is equal to 0. And so the limit is 0 in this case. So no matter how you slice it, the limit doesn't exist. You can get a plus infinity out, you can get a minus infinity out, you can get a 0 out, all depending on the path. If we choose the path along the x-axis, we get the limit 0 out. If we choose the path along the y-axis, then we'll either get plus or minus infinity, depending on whether the y is positive or negative. So the limit definitely doesn't exist. So since different paths yield different results, yield different limits, the limit does not exist. Okay, again, it's analogous to having a left side limit and a right side limit in a one variable situation that are giving different answers. And so we would say that the two-sided limit doesn't exist. In this case, we wouldn't call this a two-sided limit. There's infinitely many different directions that a point in the plane can approach some other point, that a variable point can approach a fixed point. There's infinitely many different ways, not just two. So the terminology isn't quite the same, but the idea is the same. Different paths yielding different limits means that the limit does not exist.